start out today, I'll kind of give a little bit of a background about the pond stabilizations, how it came to be in Minnesota, and then the basic principles for treatment and operation and testing, and then Colin will take over and talk a little bit about the maintenance of the stabilization ponds. Some resources that are real handy to use. In 2009, the MPCA put out a new design criteria booklet. Has some real good basic information for pond design, sizing. And then back in 1999, they also had the Operation and Maintenance Manual that came out, and that's still used today. A lot of information in this presentation are from these manuals, and this is what is enforced by the state of Minnesota. Some background is that in the upper Midwest, the first ponds were designed or were installed in North Dakota. In the upper Midwest, where we have the colder weather, this is where they first were put into operation. Dresden, North Dakota was the first in 1928. And that was an existing pond that was converted over to a stabilization pond. It was a few years after that in 1949, that decided, let's go and make a pond and let's look at the treatment, stabilization pond treatment. It took a few more years for this to catch on in Minnesota. It was basically 1955 in Albany, Minnesota. It was a treatment facility. And they catch fish. I'll tell you a little bit about Albany. 75% of the flow going into Albany was from craft food processing. So when this went into operation, it was an experiment. It was nothing tried and true. And so it was by the Department of Health, and they said you have about a year and a half. We did testing, followed up on it, and said, you know what, this is a really good treatment method. 25% of the flow was municipality flow, and then the other 75% was from craft. After about a year and a half of tests, they said, okay, you know what, this is no longer experimental. This really does work. So over the next 55 years plus, the state of Minnesota started installing stabilization ponds. And if you look at the drawing here, this is a few years old. The majority of the stabilization ponds are in the south, and then along the western corridor. The reason you don't see them here is just because it's expensive. You have a lot of rock. Stabilization ponds require a lot of land. And then if you look down here in the southeastern corner of the state, we have karst topography where there have been several that have failed where they've gone in and they've actually, operator gets up the next day, goes out there, and they're completely empty because of the karst topography. So they've taken out, or trying to remove the ponds that were down here and switch them over to mechanical plants because of that. There are several different types of ponds. You have the polishing, infiltration, storage, and then the aerated and the anaerobic ponds, which lead us to stabilization ponds, which use a treatment that combines these two in it. Polishing is basically tertiary. It's to clean it up, the final treatment. Infiltration are very low. You have a half a foot to a foot and a half of water in the pond, and it's allowed to percolate through the soils for treatment. When you're looking at storage lagoons and also anaerobic, you usually have very concentrated waste going in. Typically associate odors with these types of ponds because they are so heavily loaded and they are anaerobic. The aerated pond, this is a pond where it's aerated through the entire depth of the pond. They have either surface aerators or diffusers, and so the dissolved oxygen is throughout. And it's the stabilization pond that we're going to look at, where it kind of combines the anaerobic and the aerobic. It uses this process to both biologically break down the solids in the waste, or the wastewater, and decompose it, and then also because of the size, the solids are able to settle out into the primary pond typically. These ponds do not require mechanical aerators. They're very efficient and affordable to use because it's algae. It's stuff that's existing out there that's natural, that breaks down the wastewater. So you don't have to bring in power lines, electrical. It's all out there, it's natural. You can put these almost anywhere. For the stabilization ponds in Minnesota, we kind of have a east-west line running through the state at Brainerd. If you go north of Brainerd, you require 210 days of holding time. Below, it's 180 days, and that's just because of the temperatures. And then if you look at land application, if you do spray irrigation, again, you do require a little more time. 210 days is what it should be sized for. We look at the treatment that goes on in the pond as a symbiotic relationship. What you have is the organic matter coming in, The bacteria, which is naturally occurring in the pond, breaks down the organic matter that comes in, creates nutrients, and gives off carbon dioxide. And it's the algae in the pond that takes up the carbon dioxide, the nutrients, and then the sunlight, and it creates oxygen, which the bacteria need to thrive. And for every pound of algae, you produce almost just over 1.5 pounds of oxygen, so it's a very efficient system. Some of the impacts that we look at is the algae creates the oxygen, but to really get it below that 3-foot level, you need the wind action of a pond. And so for Minnesota, where we have the prairies, we have the open space, ponds work out really nice because we do get that wind action across the ponds. Look at temperature too. In the summer, when we do have the warmer temperatures, that's where our DO, as the temperatures go up, the saturated DO in the water comes down. When you have the colder temperatures, the water will absorb the DO much better. So if you're looking at cold water, you may have a dissolved oxygen concentration of maybe 14 parts per million, but when the water starts to get warmer, that can go up to 9 parts, so it decreases. And that's something to keep your eye on in the summer months. We look at nutrients. One of the reasons that stabilization ponds have worked so well for the municipalities is what's required is, for the BOD, the nitrogen, the phosphorus ratio, the recommended is 100 to 5 to 1, and typical wastewater is very, very close to that. So it's a very, when you're looking at municipality waste, it really matches well to what the organisms like to thrive. And again, light is another big one. Minnesota, we're fairly lucky. We do have a fair amount of sunshine, although in the winter you probably wouldn't believe it, but we average 50% to 60% of the normal time that we can have sunlight, that we do have that. In the winter it drops down to about 40 to 50%, and in the summer it's up to 70%. And this just kind of shows a stabilization pond is called a facultative pond because it has microbes or has bacteria in it that like both the aerobic that thrive on the upper layers where the oxygen is received either through wind action, and then the algae that thrive up there. And then they have anaerobic bacteria that thrive in the sludge layer down below. And then in between here, this bacteria it's real adaptable. It can take varying levels of DO. And so throughout the whole pond, you are getting treatment. In the winter, when this freezes, the majority of the pond then does become anaerobic. The hope is that as you have that 180 to 210 days out there, is that you will meet the effluent limits. For Minnesota, our typical effluent limits are 200 colonies of fecal coliform per 1,000, and then a BOD of 25, and a total suspended solids of 45 with a pH of 6 to 9. And this is basics for most facilities. We are seeing more and more where phosphorus limits are coming into effect, and I think that's something we'll continue to see become more prevalent as the regulations become a little more stricter. Design criteria, if you want to know what is the loading, what should our pond be receiving in the influent. The organic loading is 22 pounds of BOD per acre, or 0.5 pounds per 1,000 square feet. And that is the typical loading that should be going into the primary pond surface. We talked a little bit about the storage, and that is the total storage in the primary and secondary is at 180 to 210 days. Your secondary cell, based on hydraulics, is about 1/3 the capacity of the entire system, and that's how it should be designed. If you have less than that, it's something to take a look at. And then elevation difference, and this is a big one, because if you can have a 4-foot difference from your primary and your secondary pond, you can get a gravity flow through there. So when you start to discharge from one to the other, you can open a valve, drop the level. If you don't have that, and typically when you don't have it, it's because you have high groundwater. You have to keep a 4-foot separation from the bottom of the pond to the high water level. And if you can't do that, typically what you'll find out is that the primary and second pond have the same elevation, and so you have to pump. And one thing I want to spend a little time on is just the water level. What really drives the treatment is maintaining and utilizing the volume in your ponds. You really don't want to run them at the lowest possible. If you're a community where maybe the population is much less and you can get by discharging once a year versus twice a year, that's something to look at. Because by keeping your ponds low all the time, you really reduce the area where the microorganisms have to live. You reduce your dilution potential in the pond. And then as as you drop it down, you're exposing clay liners. The majority of the ponds in Minnesota have the clay liner to them. So with those low levels, you're exposing the clay liner, which then you get cracks in it, it starts to dry out, and you just increase the potential for possible leakage in the future.
When you say low, how low are you talking?
Low, well, the lowest you can take it is 2 feet. Below the 2 feet, that's your sludge blankets. So 0 to 2 is where you store your sludge. And then from the 2 to 6 foot level, that's where your operation is. If you keep 3 feet in there, that's ideal. And the reason I say 3 feet is because if you look at vegetation growth, when Colin talks about maintenance, if you don't have at least 3 feet in there, especially your secondaries, you're going to find that cattails really want to take off because you have a clear secondary and cattails spread by seeds and by waterfalls. So if they get in there and they can get the sunlight down there, you're going to have them growing in your secondary ponds. So if you can keep that water level up a little higher, the sunlight can penetrate, and that helps reduce that potential. One thing to keep in mind too is that at the high water level, you want to make sure that the riprap is at least a foot above that, especially where you have really large ponds, because that wind action, last year I was out in one of the ponds, we were doing a water balance test, and we had whitecaps out there. I mean, when it gets windy, those waves really do get pretty aggressive. And for transferring, for communities that have ponds that are 10 acres or smaller, typically what you'll find is a 2-cell. Once you go above a 10-acre surface area for the water, you have to go to a 3-cell. And so the 2-cell basically has one mode of operation where you have the raw water coming into the primary and then the transfer station here to go to the secondary. And the rule of thumb is that once the primary is 1 foot above the water level in the secondary, you use the transfer structure to transfer 6 inches over. And they minimize it only a 6-inch at a time transfer. And then if you do need to discharge, get to the point where you're discharging, make sure that you're only discharging one of these. You never discharge from more than 1 point at a time. The larger areas where you have above 10 acres or more, where you have the 3 cells and you have 2 primaries, there is a mode of operation for summer and winter that's recommended. In the summer, what is really recommended is that all the flow gets sent to 1 primary. Have it go into the primary pond 1, then transfer, when this is 6 inches above the water level of your second, transfer over to the second. And then when this is 6 inches, or a foot above the final secondary pond, transfer 6 inches over to here. And that's just because of algae. You're trying to really keep your loadings going to this so that you get the clearest water possible to your secondary. In the winter, the operation's a little different. They really recommend that you do a parallel where you're doing both the primary and the secondary, filling them at the same time. And that's just because your bacteria in the winter, they slow down and they can't consume as much. And by splitting it up, you don't overload them with organics. It's a little bit easier on the bugs and on the pond. And this just kind of describes the 1-2 cell, but basically summer series operation is due to algae levels. You really want to keep them into that primary and then slowly transfer so that your secondary is clear when you have to discharge in the fall. And then the winter, the parallel operation, and that's just to avoid organic overloading. For transfer, you asked what is the minimum depth in the pond. Most structures or most primary ponds should have the intake where it's at least 2 feet off the bottom of the pond, and this is so that you can't take the sludge. The bottom 2 feet are for the solids to fall and for them to collect. Albany, the first pond that was ever constructed now in 1955, they went 40 years before they had to be dredged. And what happens is the solids settle out here. Wastewater is about 99.9% water, so you have very small amount of solids that are settling out. So as they settle here, they decompose, and it's sand, grit, and some organics that you have settled out that you can build up over a long period of time. And that's why they really say, get this 2 feet off the bottom, your operating depth is 4 feet above that. If you cannot transfer by gravity, just a rule of thumb is that if you're going to transfer 6 inches a day, you need a pump that can pump 100 gallons per minute per acre of pond. So if your primary is 2 acres, you need a 200-gallon per minute pump. For systems that have the ability to have that 4-foot separation, they can do the gravity flow. What the MPC has done is they've switched over a number of years ago and really have recommended that you switch over to these telescoping valves. So where your primary pond, you'd be set by this level. As this is decreased 6 inches, your primary water would come into here, flow through from the primary, spill over, and then it would go into the secondary. This controls the level, and you can see the level up here. 20 years ago when I first went out, I went out with an operator, and it was just a second, he was discharging, and I'll never forget it because he jumped out of the truck, went over to the structure, and he just disappeared. I mean, and I went over there, I thought he's dead, you know? And he was down in this manhole with a probably 8-inch wide concrete wall, standing on that, and they had stop logs. I don't know how many of you remember the stop logs, but these were made out of wood. They were old-fashioned. He was down there, and he was trying to pull it off. And I OSHA would have caught him, which I think, 20 years ago, they weren't around much, but he was down there trying to pull it up. On one side, he had the sewage flowing over, and on the other side, it was discharged. So there was like a 15-foot drop. And I just thought, if this guy goes over, oh my gosh, and I didn't have a cell phone back then, so we were out in the middle of nowhere. I just thought this was really dangerous. And I think that this is, for operation, this is a huge improvement because it keeps you out of the structure. You can stand up on top, operate the hand wheel, visibly see how much you're dropping it. Here you can see, okay, I'm dropping it from the primary, it's going to the secondary, or from the secondary to the outfall. It's just a much easier and safer mode of operation. Again, leave at least 3 feet of water in that secondary pond. And the reason I say that is a couple years ago, there's incidents where the water level was dropped well below that 3-foot level. It was taken all the way down to the 2, and as you go into winter, you get those heavy freezes, fills up with ice, and the ice moves things. And this pond here, it has a liner, it's an Hdpe liner. This is what the liner looks like. It's exposed, there's a sand layer underneath it, but it's a very stiff plastic. And the influent pipe came in through the sidewall, through that, and it was completely watertight at the time, but what happened with the ice is it shifted the pipe. That ice, as it moved that whole pipe, ripped it off the side. This isn't a sludge blanket here, or anaerobic sludge. This is the liner that's bubbled up. And I did have a great picture of a duck on it before, but this is moving across as the wind was moving it around, and underneath that was water. A little bit of air and water. What happened is the water penetrated through that rip of the liner, went underneath it, and was pushing it up, which really created a huge issue. We had to drain the entire pond, go in, and correct that. So it's just something to keep in mind, that keeping at least 3 feet of water in there in the winter is really important for freezing. And just some things for improving the quality of water in that secondary cell is that summer-winter operation. When you have 3 cells, doing it either in series or parallel, that's something that you really want to take a look at to see which works best for you. In the secondary, basically it's going to deteriorate. The secondary cell typically is the one that, just because of the vegetative growth in there, it can deteriorate pretty quick. So you want to make sure that you take care of it. Keep it as clean as you can, get the cleanest water over to it as possible. The secondary, because it does have algae in it, and it has the nice sunlight, it's clean water, it creates a good level of dissolved oxygen in it. Primaries a lot of times will be low on the dissolved oxygen. And so what you can do, if you take readings here, you find out you have really low readings, you can pump from the secondary over to the primary to get your dissolved oxygen levels up. One way you know if your levels are low, you can take a look at, or if you're having issues, Daphnia, they're a larger, called a water flea. They create a reddish color in the water. When they're healthy, when they're in their secondary pond, they're great for cleaning up. They're kind of the filters of the whole system. They really provide a great effluent. You can see them from the eye, and when they're healthy, they're kind of a clear color, but when they get stressed, when the algae limit becomes diminished, and that's typically when your DO is diminished, it's when the algae starts to suffer, they'll turn red. So if you see a red color to your pond, it's an indicator there's something wrong here. We need to take a look at our DO levels, make sure that they're up there where they need to be. Discharge, you want to make sure that the very first time that you discharge, if you just had a pond system created, first time it's been in operation, the very first discharge, it's recommended that you transfer your flow over there, let it sit a month before you discharge. And this is because everything is so new in that system. After that, after the pond has been in operation, after that first discharge, it's a 3 to 4 day window is what's recommended. Transfer, wait 3 to 4 days, then do your testing. Testing is required prior to discharge. What you're looking at here is you want to make sure that the BOD has been reduced properly. The TSS, the algae, you'll see that the zooplankton Daphnia will eat up the algae in the secondary cells. And then the fecal, that'll be destroyed through the sunlight and then also through algae and toxins within the water. I think the TSS is probably the one that most facilities have the hardest time meeting. BOD has not been as big of an issue, at least from what I've seen discharging. When the BOD or when the waste is sent into the primary pond, it's typically 30 to 45 days for the bacteria to break down the BOD. It happens fairly soon. It's typically probably 80% of it happens in that primary pond. The TSS, your settling is going to happen almost immediately. However, if you have a lot of wind action, that can be riled up. So when you do transfers, you want to make sure that you're transferring on a fairly calm day so you're not taking all those solids over. Especially if you have a phosphorus limit. What we've seen is that when ponds first start out, that first year or two in operation, they do great. They don't have any problem with phosphorus. And then year 3 or 4, when they start having the higher phosphorus, and that's just because they're starting to get solids in the pond. They're starting to build up, and then that wind action is coming in. It's stirring it up, and the phosphorus is attached to the solids. So as those solids build and get into the flow, your phosphorus is quite a bit higher. Testing. MPCA requires that you take 4 grab samples before you discharge from each corner of the pond. So that secondary pond sample has to be taken from 8 feet out and 1 foot below the level. And they looked at what's a really easy way to do this, because it isn't the handiest thing to do. And this is a little sampler that I think is really neat. It's sold by NASCO. It's about $120, and it's got a telescoping handle on it. So you just unscrew it, it goes out like a painter's handle, it goes way out, and you can dip it into each corner. Take their samples with the sample container right here, dip it in, works out really nice, and then what they do, you can flip that unit, and it's got little pinchers, so you can take sterile baggies and connect those onto there for taking your fecal, because you have to have a sterile container for your fecal. It works out really nice, and you may have other methods, but I just thought this is one I'd share with you, because I know this is one that's worked really well. Once you have your sample, you want to make sure that you do keep it refrigerated, get it to the lab right away, and then it arrives within 24 hours or to the lab. One of the things that when you do discharge, you want to make sure that it's within that 2-week period. If you initiate discharge after that, you can get a violation, so you have to make sure that that initiation is not any more than 2 weeks after that testing. The samples have to be taken from the secondary, and then make sure too that when you're doing the testing that your DO is at least 5 parts. And right the day before discharge, you also have to check your pH and then your the DO there. Fecal coliform, again, should be received by the lab within 24 hours of sampling, just so it's accurate. And again, excess wind. Make sure you don't test when you have a really windy day, because it's going to really corrupt your tests. You want to make sure it's a calm day when you go out there to do that. If you do not meet the limits, let's say your BOD is high, first thing to do is look at the source. Is there someone dumping something in there? We've seen all sorts of things. People going to manholes and dumping their septic into it. We've had farmers dump certain things in, so you have to kind of make sure you watch your whole collection system, make sure that there aren't any points where people can dump things into it, because it does happen. If you are having an issue, if you are not in parallel operation and you have 3 cells, switching to parallel operation will help. And then there are growth enzymes, and I don't know anyone who's done this because it is expensive. I don't know if there's anyone here who's tried the growth hormones. How did it work? Doing good? Okay. TSS reduction, the one that I guess we recommend first is the alum, because it's easy to use, it's fairly inexpensive. When you look at the ferric chloride, that is just a nasty chemical to work with, not user-friendly at all. The next item that you can use is potassium permanganate, but that's expensive. And the EPA recommends using the hydrophil 191. That's probably double the cost of the potassium permanganate, so I don't know anyone that's used that. I don't know if anyone here has tried that, hydrochlor. You have? Okay. Pretty good results, or? Yeah. Okay. And then copper sulfate is one that you can use. You do not use that if you're going to be discharging. You're going to use it in the primary pond. If you can avoid using it at all costs, I would. They don't know what the impact of that is yet into the environment. And fecal, reducing the fecal, that is done through adding chlorination, disinfection. You can either use sodium hypochlorite or you can use sodium hypochlorite. I would not use this. This is an explosive. It's dangerous. It is a recommended or an approved method, but sodium hypochlorite, that's what I would stick with if I were you. And that's for a batch treatment. If you have a real long outflow line where you have at least 30 minutes detention in your line going out, then you can add like pool chlorine, the THC, add that into the line as it goes out. And that way it will do the kill for you. Whichever method you use, you want to make sure that as it hits the receiving stream that you have less than 0.1 parts per million of chlorine in there. Odor control. Typically, you have an odor issue in the spring. I think a lot of people associate ponds with odors. Stabilization ponds typically do not have that odor to them. In the spring, when you're going from an anaerobic phase to the aerobic phase, 3 to 10 days, you might have a musty smell or kind of that pond smell in the spring that other ponds have. If you do have excessive loading and you have an issue with that, what you can do is add hydrogen peroxide. That works almost immediately. Within minutes it should work. You broadcast that out, and that is very effective. Sodium nitrate is another method that can be used, and that you have to use quite a bit of it. You're looking at about 100 pounds per acre for the first day, and then you're looking at another 50 pounds per acre per day after if the odor persists. So it's a little bit more time consuming, a lot more chemicals added. Discharge window, depending on where you're located, to the north, if you're serviced by Brainerd, Detroit Lakes, Blue offices, typically the standard is that you're going to have about a 2-week longer discharge period in the spring and fall than you are if you're located in the southern part of the state, and that just has to do with temperature. And the maintenance, I'm going to turn over to Colin for that.
Are you going to talk about pH or DO problems?
I can too. Does one go first, or? Okay. Does I go first?
Hi everyone, I'm Colin Marcusen, I'm with SUH. Talk a little bit about pond maintenance. So we'll go through vegetative control both in the ponds and on the dikes. We'll talk about erosion control on the dikes themselves, and then we'll talk a little bit about burrowing animals. Vegetation that can occur in the ponds themselves include all these things: submerged weeds, marsh plants, deep-rooted plants, and then maybe not as common unless the ponds have been neglected as far as maintenance are shrubs and trees. But they can be a big problem. We'll talk about those as we go on. And just so you know, we're going to fly through this stuff a little bit. It's pretty basic. So, cattails are in the marsh plant category, and they're really the most troublesome plant as far as ponds go. They spread quickly, easily cause damage to the liners, and as they spread, they kind of form a quiescent zone, I guess, if you will, around the outside of the pond, which doesn't allow for as much mixing inside the pond. And in extreme cases, you can even get some short-circuiting due to too many cattails. Removal of cattails is not easy. If you catch them in the first year, which isn't very common, they can be pulled out. Again, that's not easy, but Karen kind of mentioned before, the best method for removal is the cut and drown method. So what we do is drain a pond at minimum 2-foot water level depth. Cut down all the cattails you can, and then fill the pond as full as possible, at least 3 feet above where you cut the cattails off. And hopefully that'll drown out cattails. It might take several iterations that method, but so it's pretty labor intensive, but hopefully that works. You can also spray, but again, it might take several iterations of that. That cut and drown method is best performed in, it says June or mid-July, to get them on the fall. Bull rushes are not as common as cattails in ponds, but we do see them. They're even tougher to get rid of, usually by the same method as cattails. The cut and drown method or pulling, I guess, are the best methods for removing cattails. Spraying, again, usually takes several iterations. Duckweed is also very common in ponds and lakes around Minnesota. We see it everywhere. It's usually not a big problem. It can actually assist in treatment in small amounts, just because it reduces oxygen and gives you some better DO. However, if extensive mats are created with duckweed, it can block sunlight, which will inhibit photosynthesis and therefore decrease your DO. The mats are usually broken up by wind and wave action, so it's not typically a big deal. Again, removal of duckweed. It's not usually a big deal. Ducks can sometimes turn up the water enough even to break up the mats. You can skim the ponds to remove it. As I said, it's typically not necessary. Vegetative control on the dikes. Usually this just entails keeping a good stand of some good grass growing on the dikes to prevent any wind and water erosion on the dikes. Best grasses for growing on the dikes are rye and brome or quackgrass. The reasons for those are they're not easily uprooted, so they're good for erosion control. As with any grass, the better you maintain it, the easier it is to maintain. So mow it frequently. Frequently is 3 to 4 times each season. Harmful vegetation on pond dikes can include things like trees, shrubs, or deep-rooted weeds. The only thing I really want to say about that is if you find them, take the time to remove them. And again, you probably won't see them until, or if there's been a neglect in some maintenance. But again, if you see them, take the time to remove them. But wear your personal protective equipment. Riprap is not easy to walk on. The most harmful that we see are poplar trees, cottonwood trees, willow trees. Just because they spread so fast, their seeds spread so fast, and you can find them in the riprap. Erosion control, the main point there is just to say inspect your dikes regularly. Make sure that your riprap is in place. As far as wave action, we really don't see much of a problem until we get into some larger ponds, and then the wind can really create some big waves and start washing away the sides of the pond dikes, even riprap and even the liner. And once that erosion starts, it's hard to stop it, and it'll go quickly. Can even wash away liner material. To prevent some of that wave action, make sure your riprap is at least a foot above the high water level of the ponds. And extends all the way down to the toe of the slope, all the way down to the pond bottom. Anything really can be used, 3 to 15 inches diameter for rock. You really don't want to go much larger than 15 inches, just because animals have a tendency then to burrow underneath those larger pieces of riprap or asphalt or concrete or whatever you put out there, and then burrow into the dikes. And that takes us to animal control, muskrats, badgers, and gophers. Badgers and gophers, typically not a huge problem. They burrow in from the outside of the dikes. Where it can be a problem is where they combine with a muskrat tunnel. I'll show a photo of that later on. But the main goal here is to, as it shows, channel your inner Bill Murray and come up with some inventive muskrat or gopher and badger removal ideas. To be clear, I'm not telling you to use explosives under pond dikes, though. Muskrats, they're really the big problem when it comes to pond dikes. They'll burrow in from the water side. They'll start their burrow from 6 to 18 inches below the water level, and they'll tunnel in quite a ways, as you can see on the photo. And like I said, from the outside then, gophers and badger burrows can meet up with a muskrat burrow, and then you've got a permanent leak through your pond dike. Once that leak is started, especially if it's below the water level, that hole just keep getting bigger and bigger, and you'll really have a problem. Maybe even catastrophic for the pond dike. So watch out for muskrats. You know the best ways to remove them. I'm sure all of you are well aware of the benefits of a rifle, so I won't go into that very much. Floating mats, just another maintenance issue I'll talk about quickly. Sludge mats, black in color, usually show up sometime around ice out. Usually have an odor with them, as most city residents know. It can also form in the middle of the summer. If that happens, that's more of an indication that your pond is organically overloaded. Flow might have to be redirected to a different pond cell for a little while in order to get your balance right in that pond again. Or as Karen said earlier, you can pump water from the secondary cell back into the primary to try to get that DO back up there. Blue-green algae. Again, pretty common in Minnesota, especially end of the summer. The biggest problem with blue-green algae is that they're poisonous to the animals that might try to go and drink water out of the pond, dogs, or whatnot. Again, they can be an indication of high organic loading. So again, divert the influent to another cell, or feed better water back into that cell. Oil and grease mats can be a real nuisance to a pond system. They can kill off bugs in the pond pretty quickly. The first thing to do when you find an oil and grease sheen on your pond is you got to determine the source and get rid of it. So once you've done that, then you can go back and figure out how to remove it. What we've seen done is absorbent mats or pads, straw, or even corn cobs are put in ponds to try to absorb some of that oil or grease. The last thing I just wanted to go through, regular pond maintenance items just to make your life easier. Excuse me. So in your control structures, regularly lubricate and exercise your sliding valves or sliding gates and valves, so that you can be assured that you can use them and really need them. If you have long force main run or even a long gravity sewer run to where your ponds are, it's a good possibility you have a lot of problems with H2S gases, which are highly corrosive to both concrete and metal. So that second item there says if you want to replace a solid cover, you want to replace a solid metal cover with an open graded cover in order to let some of those gases release. That can really help with some of your corrosion issues inside those animals. Lastly, just look for leaks in pond dikes especially, but also in piping and in your structures. Mosquito and insect control, not typically a big deal at wastewater ponds, especially if the grass is mowed regularly and there's regular weed control, that kind of thing. Larvicide can be used if it becomes a big problem. And lastly, solids accumulation. Ponds are designed so that there's typically not very much solids accumulation, especially probably for the first 20 years or so. In fact, Albany went 40 years without doing any sort of solids removal in their ponds. But just watch for accumulation, especially at the inlet pipes or quiescent zones, be around cattails or things like that. And removal options would be vacuuming or dredging. And Karen's going to talk about a couple more issues.